After more than a decade, the U.S. Navy is making slow but steady progress on its futuristic railgun. If the program can produce a functional and cost-efficient weapon, it could give the U.S. Navy ships a deadly new way of attacking enemy vessels and forces ashore, as well as defending against aircraft and fast-flying missiles. In this video, Defense Updates looks at why Railgun is a game-changing tech and how close the U.S. is to having it operational.
Number 5.
A conventional cannon has some type of shell in a tube. The shell is then launched by the expansion of exploding gunpowder. The traditional guns have three major limitations. 1. Gunpowder must be carried with the projectile, making the entire round heavier. 2. Ordnance based on gunpowder is volatile and so difficult to handle and transport. Their presence also makes the ships vulnerable, as the ammunition containers can explode even with a single direct hit from a torpedo or anti-ship missile, resulting in grave damages. 3. The muzzle velocity of projectiles propelled by gunpowder is generally limited to about 4,000 feet per second, or 3.5 Mach.
Number 4.
A railgun is an electromagnetic projectile launcher. A railgun uses a pair of parallel conductors, or rails, along which a sliding armature is accelerated by the electromagnetic effects of a current that flows down one rail into the armature and then back along the other rail. Railguns use neither explosives nor propellant, but rather rely on electromagnetic forces to impart a very high kinetic energy to a projectile. Their projectiles can reach speeds of more than 7 Mach. The absence of explosive propellants or warheads to store and handle, as well as the low cost of projectiles compared to conventional weaponry, comes as great advantage.
Number 3.
Making an operational railgun is easier said than done. Here are some challenges. 1. The railguns rely on an electromagnetic field to propel the projectile, and for that, a lot of electricity is required. This is one of the major reasons that the U.S. is replacing some of its Nimitz-class supercarriers with Ford-class carriers. Ford-class has newly designed reactors. 2 Bechtel A-1B nuclear reactors are installed on the USS Gerald R. Ford. Each one of these are capable of producing 300 megawatts of electricity, triple the 100 megawatts of each Nimitz class. 2. In current designs of railgun, massive amounts of heat are created by the electricity flowing through the rails, as well as by the friction of the projectile leaving the device. This causes 3 main problems: melting of equipment, decreased safety of personnel, and detection by enemy forces due to increased infrared signature. 3. A system like this needs time to cool down, so the gun cannot be used in bursts to fire lots of rounds in small duration of time. 4. The current designs are huge in size. They take a lot of space. This makes them hard to accommodate in ships or transport them like modern howitzers.
Number 2.
The U.S. Navy plans to integrate a railgun that has a range of over 160 kilometers, 100 miles, on a ship by 2020. The U.S. experts want the rounds to weigh about 10 kilograms, around 18 inches in diameter, and have a speed of around Mach 7. The U.S. Navy is pursuing development of the launcher system through 2 industry teams, General Atomics and BAE Systems, to reduce risk in the program and to foster innovation in next-generation shipboard weapons. In 2012, BAE Systems demonstrated a 32 megajoule prototype at the Naval Surface Warfare Center in Dahlgren, Virginia. In March of this year, the U.S. Navy Office of Naval Research has released new video of a test of BAE Systems' electromagnetic railgun that has a maximum range exceeding 100 miles. Capable of accelerating a projectile from 0 to 6 Mach in just over 10 milliseconds, the test videos have shown it cut through over 6 sheets of steel plating like butter. General Atomics committed more than $50 million in internal funding last year for railgun development in hopes of attracting renewed Army and Navy interests in the technology. In March of 2017, General Atomics proudly announced it had built a new high-energy pulsed power container, HEPPC, for its railgun variant, which had twice the energy density as the previous model. The company is currently performing risk reduction testing in order to ready the technology for possible deployment.
Number 1.
Assuming that the many technical challenges facing railguns are overcome, including issues like heat dissipation, rail endurance, and combat survivability, and reliability of the electrical power supply, the increased launch velocities of railguns will provide multiple advantages over more conventional guns for a variety of offensive and defensive scenarios. The railguns obviously have a great offensive role to play in the future. Ships equipped with railguns have much higher firepower owing to their ability to load more ammunition. Railgun rounds will also be inherently very destructive due to their high velocity. But the railguns have an equally important role to play as a defensive weapon. Russia and China, who are the main rivals of the U.S., have developed a series of supersonic anti-ship missiles which are hard to defend against with current crop of anti-missile defense systems. Russia is also working on hypersonic versions of BrahMos and testing Zircon cruise missile, which has a speed of more than 6 Mach. There is currently no way to stop hypersonic missiles. Once the railguns are ready, U.S. will have a much better chance of intercepting these missiles before they hit the ship. A future goal is to develop projectiles that are self-guided, a necessary requirement to hit distant targets or intercepting missiles.
Thanks for watching. Subscribe for more videos like this. Hit the like button if you find the video interesting. Kindly provide your feedback in the comment section. This will help us improve.